Hello, Calculus 1 students. Let's work this previous midterm test of mine. You will see the directions. In fact, these will be the exact same directions on our midterm test. Well, we have three parts where we need to evaluate each limit or show it does not exist. Okay, the first one, generally our strategy here would be we try to evaluate. You notice when I try to evaluate at x equals 3, I get 4 squared minus 16, which is 0, divided by 3 minus 3, which is 0. So this is an indeterminate form. It does not say the limit exists. It does not say the limit does not exist. What this says is we need to do more work. In this case, I will need to multiply out this 1 plus x squared, which will be 1 plus x times 1 plus x. We get x squared plus 2x plus 1. Then I'll need to refactor my numerator. So I have a limit as x approaches 3. We have x squared plus 2x minus 15. Now I'm ready to try to factor. Well, the negative 15 says we need a minus and a plus. I need two numbers that multiply to negative 15, add to positive 2. Okay, let's try minus 3 and plus 5. And you can check that this works. Well, now we're almost finished. We have a limit as x approaches 3 of x plus 5. Because this part, x minus 3 over x minus 3, we can cancel that off. So I just get 8. Next one. Well, you notice it looks the same. I have 1 plus x squared minus 16 over x minus 3, but this is a limit at 0. Here, we can just evaluate because I do not get an indeterminate form. I get 1 minus 16 divided by negative 3, which is negative 15 over negative 3, positive 5. Now, just as a remark, we could have evaluated this at 0 because of the simplification we had done, but I just treated this sort of as a new question. I just evaluated at x equals 0. Okay, next one we have a limit at infinity. So what we need to do, divide every single term by x to the highest power that we see. In this case, we see x to the 5th. So I have 2 over x to the 5th minus 4x to the 5th divided by x to the 5th. In the denominator, I have 36x squared over x to the 5th plus 3x to the 5th over x to the 5th. Now, I am ready to use properties of exponents. Let me make this a little smaller. We have a limit as x approaches infinity. Well, I have 2 over x to the 5th minus 4. My denominator simplifies to 36 over x cubed plus 3. Now we're ready to evaluate our limit because this term goes to 0. We have a fixed numerator. Denominator is growing without bound. This term goes to 0. Once again, fixed numerator. Denominator is growing without bound. So my final answer is negative 4 divided by 3. All three of these limits exist. Number 2, parts A and B, we have a piecewise defined function. No justification is needed. First, you notice we have a limit as x approaches minus 10 on the left. We have a limit as x approaches minus 10 on the right. So minus 10 on the left, we use values less than minus 10 and approaching. So we get, this will be 100 minus 40, which is 60. The limit as x approaches minus 10 on the right, we use values bigger than minus 10 and approaching. We evaluate here. This will be the absolute value of negative 35. So this is positive 35. Now, the limit from the left does not equal the limit from the right. Therefore, the overall limit does not exist. Function value. Well, the equals is here, and so we get 35. Is f of x continuous at x equals minus 10? No, because the limit does not exist. Very nice. Now we have definition of derivative. We're given f of x is 1 over 3x minus 1. We want to find f prime of 2 using the definition. If we use rules here, we receive 0 points. So we absolutely must use the definition. What I do is start with the numerator, f of 2 plus h minus f of 2. Okay, 1 over. Now, we put in 2 plus h for the x. We have 3, 2 plus h minus 1. Subtract off. Well, when we evaluate at 2, you notice we get 3 times 2 minus 1, which is 5. That is in our denominator. Maybe I'll do one more step here before I try to get a common denominator. Here, this denominator, we have 6 plus 3h minus 1. So that will be 3h plus 5. Plus 5. Okay. The strategy on these types of questions is get a common denominator. Here, we just multiply the two denominators. So I multiply here by 3h plus 5 divided by 3h plus 5. The other term I multiply by 5 over 5. Okay, we're trying to get this numerator, f of 2 plus h minus f of 2, as h times something, so that when I divide by h, in the difference quotient, the h over h cancels. We're very close to being there. You notice when I add these two fractions, I get 5 minus 3h minus 5. I have distributed this negative across the parentheses and then divided by my denominator. I will just leave as a product. It is 5 times 3h plus 5. This is negative 3h over this denominator. Well, this is h times something. So I'm ready to divide by h, and then we can take a limit as h approaches 0. I might do that in one step. So we want a limit as h approaches 0. We take this expression and divide by h. Okay, that will be minus 3 over 5, 3h plus 5. This is my derivative evaluated at x equals 2. Well, this is now defined at h equals 0. This is. So we just substitute h equals 0. We get negative 3 over 25. This is f prime of 2. Number 4, we are given 4 over the square root of x. We want average rate of change from 4 to 9, and then we want an equation of the secant line. Okay, great. Well, what I want is g of 9 minus g of 4 divided by 9 minus 4. This is our formula for average rate of change on an interval. Change in g over change in x. I usually come to the side. So g of 9 is 4 over the square root of 9, which is 4/3. G of 4 is 4 over the square root of 4, which is 2. So g of 4 is 2. Now jump back into my quotient. I have 4/3 minus 2 divided by 5. 2 is 6/3. So I'll do it this way, 4 minus 6 over 3, and then times 1 over 5. So I get negative 2 divided by 15. This would be my average rate of change of g of x on the interval from 4 to 9. Now, we have already found the slope of the secant line in part A. So we have two choices for a point. We could use 9, 4/3. We could use 4, 2. I think I'll use 4, 2 because both coordinates are integers. So I will use 4, 2. Now we have a slope. We have a point. We can write down an equation. Y minus 2 is minus 2 over 15 times x minus 4. This is number 4. Number 5, the number of matings observed among insects in an hour is given by this function, m of t, where t is the temperature in degrees Celsius. What is the rate of change of the number of matings when the temperature is 16 degrees? We need to interpret this in terms of what are we calculating here? So the first thing that's important to read is we are calculating a rate of change. This says we are calculating a derivative. Well, then we want the rate of change at 16. So what we want here is m prime of 16. Now, if you stare at m of t, this is power rule on each term. So we will take the derivative using the power rule, then evaluate at t equals 16. Wonderful. Well, m prime of t is, we have 4 times 3/2, which is the same as 2 times 3. So we have 6 t to the 1/2. And then we have plus 2 times 1/2, which is 1 t to the minus 1/2. Well, I need to evaluate this. So you could use your calculator here, but I'm going to write this in terms of square roots. It will be a little bit easier for me to evaluate by hand. So this is 6 times the square root of t, and then plus 1 over the square root of t. This is my derivative. Okay, so now m prime of 16. We have 6 times the square root of 16, which is 4, plus 1 over the square root of 16, which is 4. This is 24 and a fourth. Let's see, I will just write this as a decimal, which this is an exact answer. It is not rounded. 24.25. Very nice. Okay, I love this next question. You notice we also have a square root here, but the point 0, 2 on the graph of g of x is the square root. X squared plus 4 is a critical point for g of x because no justification needed. Well, if you have a graphing calculator that you're using during the test, you can graph it and make your decision. But I'm doing this without a calculator, so I will just take the derivative and see what happens. Okay, so maybe I will write this smaller in black. G prime of x. Chain rule. My inside function is x squared plus 4. My outside function is the square root of x. So we have derivative of the outside evaluated at the inside, and then times the derivative of the inside function. Now, stare at this derivative. Maybe I will make it slightly smaller. We could simplify this. Maybe I will to make my point here. 1/2 times 2 is 1. And then in my numerator, I have an x. And in my denominator, I have a square root, x squared plus 4. Okay, now we can see. If you evaluate this derivative at 0, we get 0. So the answer is this one. Just as a remark, these two are not related to the question because the point 0, 2. 2 is a y value here, so it's not really related to this question. We would really be looking at the x value. Okay. Next question, we have y equals f of x. Now, we are told f, we are told f prime, we are told f double prime. In this question, we do not need to calculate any derivatives, but we need to use them. So, first, list the critical numbers, which are x values. Okay, what am I working with? For critical numbers, we are working with the derivative. So, f prime of x equals 0 when, well, either, let's see, x plus 1 squared is 0, meaning x plus 1 is 0, or 2x minus 7 is 0. So we will have two critical numbers here. Okay, the first one, we get x is -1. The second one, let's see, add 7, divide by 2. We get x is 7/2. Next part, we want the open intervals of increasing and decreasing. Now, this function is a polynomial, so the domain is -infinity to infinity. Okay, we divide the domain into open intervals based on the critical numbers. So we have 1, 2 critical numbers, -1, 7/2. Typically, I'll write my open intervals underneath. Here we have 7/2 to infinity. We have -1 to 7/2. And then I have -infinity to -1. Now, I will make a chart. What's important here is to make it clear what you are working with. So this is about increasing and decreasing. I'm working with the first derivative. My first derivative is 2x plus 1 squared times 2x minus 7. Now, we need to pick a point in each interval. Really any point. What matters here is the sign of the derivative. So I can pick -2, I can pick 0, let's say 4. We are testing -2, 0, and 4. The thing is, this part, it's a square. So it is always positive. Now, 2x minus 7 at x is -2 is negative, at x equals 0 is negative, at x equals 4 is positive. So my derivative goes negative, negative, positive. Let's write it. We have negative, negative, positive. Now, we just need to make our final answer. My function is increasing everywhere I see a plus, which is 7/2 to infinity. My function is decreasing everywhere I see a minus, which is -infinity to -1 and -1 to 7/2. Next one, based on B, classify each critical number as corresponding to local max, local min, or neither. Okay, what I typically do is I just recopy my number line. So I have critical number -1, and I see minus minus. I have critical number 7/2, and I see minus plus. Minus plus. Very nice. Now, here comes sketching. At -1, sketch anything We have decreasing, horizontal tangent decreasing. So we conclude -1 is neither. All right, at x equals 7/2, sketch anything. Decreasing, increasing. We see x equals 7/2 corresponds to local min. These are my two answers here. Maybe I will just box this. Okay, number 4. On what open intervals is the function or the graph of the function concave up and concave down? Well, let me go back up. Now, change my highlighting. Concavity, we are working with the second derivative. Maybe so we can look at this as we are working the problem, I will just paste this from the top. Here's my second derivative. Okay, so first of all, my second derivative is 0 when, well, either x plus 1 is 0, that would give me x is -1, or x minus 2 is 0, that would give me x is 2. So let's divide our domain into open intervals based on where the second derivative is 0. We can also just comment that the second derivative exists everywhere. So the D and E part does not happen. We have -infinity to -1, we have -1 to 2, and we have 2 to infinity. Now, let's make a chart. And I just move some things around, but we want to pick a point in each interval and test the sign of the second derivative. This is concavity here. So we pick. I can pick 3. I can pick 0. I can pick -2. Let's put them in our chart. We have -2. We have 0. We have 3. Okay, -2 plus 1 is negative. -2 minus 2 is negative. 0 plus 1 is positive. 0 minus 2 is negative. 3 plus 1 is positive. 3 minus 2 is positive. So we have positive, negative, positive. Let's write it. It goes positive, negative, positive. Now, we get ready to make our conclusion. The graph of my function is concave up. Everywhere I see a plus, which would be -infinity to -1 and 2 to infinity, the graph of my function is concave down. Everywhere I see a minus, which is this one open interval, -1 to 2. And I have boxed that part. Last part, well, list the x values of all inflection points. You see the possible inflection points are here, -1 and 2. It also is the case that, if you notice at -1, the graph goes from concave up to concave down. And then at 2, the graph switches from concave down to concave up. So these are both inflection points. This was a wonderful question. Okay, differentiate each function. Do not simplify. Show our work. Well, we have 3 functions. Let's see. P of y is the sum of 2 terms. The first thing I'm going to do is just rewrite the second term as a power. So P of y is 4 sine of ln y plus, we have the 8th root of y cubed. That would be y to the 3/8. Okay, now I'm ready to differentiate. This first term, we have chain rule. My inside function is natural log y. So the derivative of sine is cosine. We put in the entire inside function. Then multiply by the derivative of ln y with respect to y, which is 1 over y. Then we put a plus. Now the second term is just power rule. We have 3/8 y to the minus 5/8. Okay, there's my derivative. Oh, we have two that are p. Well, this is p of y, and here's p of x. Okay, fine. That's how it turned out on this problem. So this next one, we have chain rule. So my inside function is e to the x squared plus an eighth. My outside function is x to the minus 5. This part is just a constant. Derivative of a constant is 0. Let's get started. We have p prime of x. So here is derivative of the outside. Oh, put in the entire inside function. Then multiply by the derivative of the inside function. Well, when we differentiate e to the x squared, this is a chain rule because up inside the exponent of b, that's our inside function. So we have derivative of the outside evaluated at the inside and then times derivative of the inside function. Okay, that had two chain rules in it. It was wonderful for us. Letter C, 3x to the 5/3 divided by cosine x squared. I am going to use the quotient rule. So I have the denominator times derivative of the numerator, which would be 5x to the 2/3, and then minus the numerator times the derivative of the denominator. This is chain rule. 2 cosine x times minus sine x all over. Well, if you take cosine x squared and you square it, this will be cosine to the 4th of x. Okay, that was our quotient rule. Next one, 7x e to the x. We want the slope of the tangent line at x equals 0, and then at which x value is the tangent line to f of x horizontal. This is product rule. So if I go to take f prime of x, we have first derivative of the second plus the second derivative of the first. Product rule. Well, the slope of the tangent line to the curve at x equals 0, we just evaluate. So f prime of 0, we get 7 times 0 plus 7 times e to the 0. Well, e to the 0 is 1, so my answer is 7. Letter B, at which x value is the tangent line to the graph of y equals f of x horizontal? Here we set the derivative to 0, solve for x. So we already have the derivative. We set it equal to 0, solve for x. Well, I have a sum of two terms. We want to factor out what's common to both terms. Both terms have a 7e to the x. I'm left with x plus 1. Now, 7e to the x is never 0. In fact, 7e to the x is always positive. So the only possibility here is x plus 1 equals 0. We get x is -1. Number 10, we have a beautiful picture and we have 4 true or false questions. First of all, the average rate of change of the function on the interval from -9 to -2 is negative. Okay, certainly if you took these 2 points and connected them with a straight line, that line would have negative slope. So this is true. Letter B, the point, -1, 0, which is here, is an inflection point. Well, look on the left. You see concave down. Look on the right. You see concave up. So this is also true. Letter C, the point 0 minus 3, which is here, is a critical point for the function. This is not true. You can see, kind of draw a tangent line, we can see the instantaneous rate of change at x equals 0 is negative. So this is not a critical point. Finally, the second derivative at x equals 0 is negative. Well, here is the point at x equals 0. We can see here, this function is concave up on the interval, let's see, open, say, -1 to infinity. In particular, the second derivative at x equals 0 would be positive. So this is false. All right. Last question. We want to calculate dy dx when y squared plus sine pi y is 4x. This question is very similar to one I have in a video recently, but we will still work it. It's a wonderful exercise. Okay, first, we have product rule. So when I go to differentiate x squared y, we have first times the derivative of the second. The derivative of the second is 2y dy dx. Then we put a plus, and we have the second times the derivative of the first. Well, the derivative of x is 1. We don't have to write it. Maybe I only will in my first step. Okay, that was product rule. First derivative of the second plus second derivative of the first. Then we put a plus. Now here we have chain rule. So the derivative of the outside is cosine. Evaluated at the inside. Okay, times, well, the derivative of pi y is pi dy dx. Okay, the derivative of 4x is 4. Now I have differentiated everything. Okay, as I have said multiple times, we have a left-hand side, we have a right-hand side, we have an equal sign. That's what every step should look like. On the left-hand side, we can factor out dy dx from two of the terms. We will have 2xy plus pi cosine pi y all times dy dx. But then this term has no dy dx. We need to move it over here. So the right-hand side will be 4 minus y squared. Last step. You see, here's where we want to be in our second to last step. We have something times dy dx equals something else, equation. Last step is we divide. So dy dx equals 4 minus y squared divided by 2xy plus pi cosine pi y. This is my final answer. All right. Well, I hope this video is helpful for all of you. Good luck on our midterm.